Hey folks, this is an introduction to vectors in this particular section. Let's talk through some terminology first of all. So as far as the vector is concerned, every single vector is going to have an initial point. This is going to be where the vector begins, and it's also going to have a terminal point where the vector ends. So what I want you to think about is earlier in this semester, we had something else that had a starting place and an ending place. So for your embedded question on this video, think back to an earlier chapter when we were first starting out with trigonometry and come up with a figure that we had a starting place and an ending place and talk about that. Now, what does a vector look like? A vector kind of looks like a segment, except for the fact that the deal with vector is that we're always interested in how long it is and what direction it's going. So in this particular picture that I've drawn you, maybe this first point here is my starting point, and the second one that I'm marking is my ending point, and the direction maybe is like this. Now, understand that this is not how we draw a vector. I don't understand why someone decided to put the arrow on the ending point, because then this makes you feel like the vector is going to go on forever and ever and ever. It does not. So just understand the arrow is only indicating what direction it's going. It's not telling you that it's going to go on forever and ever and ever. All right, moving on in our terminology. A scalar, this is just simply going to be a number that is multiplied by our vector. Then let's talk about a special type of vector called the position vector. So the position vector has a couple of properties. The first thing is that the initial point of a position vector is always going to be at the origin. Secondly, the terminal point is always going to be at a random coordinate. And I'm going to say that that coordinate is either going to be marked with an XY or an AB. I know you know that those are the same things, but in the rest of chapter 11, we're going to talk about both sets of letters, either an XY or an AB. Now, if I want to write a position vector, I'm going to use one of two ways to write this vector. One of them is using pointy brackets, and so I take my coordinate and I put it inside of pointy brackets, and this automatically tells me it's a position vector. And the second way that I could do this is by using i's and j's. And so I could either write this xi plus yj, where my x and my y are from my coordinate, or the more common one is the ai plus bj, where the a and the b is from my coordinate. All right, term number 5 is magnitude. What is a magnitude? It's just simply how long the vector is. The way that we write magnitude is going to be using, it looks like the absolute value bars, but this actually reads the magnitude of vector v. The way that we find our magnitude is going to be by using the Pythagorean theorem. And quite frankly, you've done this on many occasions because you have been finding a hypotenuse or finding the radius. That's the same thing as finding a magnitude. The direction angle of your vector is simply what direction is the vector going. And so the way that we write this is just by using theta. So this isn't any different from how we have been writing our angles the rest of the semester. There's two ways to find your direction angle. You can use SOHCAHTOA if it's on the unit circle, or you can use inverses if it's not a memorized value on the unit circle. And then the last, this is not necessarily terminology, but the last property here, if two vectors are equal to each other, then that simply means that both their magnitudes and their direction angles have to be exactly the same.